Good morning, everybody. Welcome to another video of watching my hands. Implicit differentiate. Good job on turning in your test. I haven't looked at them. I just saw the emails. I'll grade them over the weekend. Get them back to you on Monday. You want to start building your OCC portfolio through your Google Classroom folder. All homework assignments, test quizzes will go in there, and that'll be the evidence towards your grade. I'm just going to do like 4 examples of implicit differentiation and then give you some more problems from that same page. You have a set of problems that are due on Monday, and this next set of problems will be due on Tuesday. Okay, so I'll do one, and then maybe you can turn the video off and try the next ones and then watch me do it. But implicit functions, the thing about them is it's very hard to solve for y, but you still can graph them. I just went to Desmos and searched implicit function plotter and made the graphs just to take a look at them. They're powerful. They make some pictures that are very useful. Right. So the thing with implicit differentiation is you have to assume y is a function of x and then use the chain rule. So you're going to take the derivative of both sides of the equation with respect to x because you're assuming everything's a function of x. So you just put the d dx symbol on one side or the other, and you're just going to differentiate both sides of the equation. If we have just x's, it's just like normal. Okay? And then this is a product, so you have to use the product rule. So you're going to end up with 2 terms. So I'm going to do the first times the derivative of the second. The derivative of y is the derivative of y. So it's just going to be x times y prime. Okay. First derivative of second plus the derivative of the first times the second. The derivative of x is 1. Now when you come to a power of y, use the chain rule. So think about this as a function inside parentheses. Bring down the exponent, leave the base alone, reduce the power by 1, and then use the chain rule to take the derivative of the base. The derivative of y is y prime. And then the derivative of 27 is 0. Okay. So this is the derivative. Okay. But I'd like to take this and solve for y prime. So at this point, I'm just going to rewrite this and simplify it. So 3x squared Now there's more than one term with y prime. So a way to solve this for y prime, and this will always work, take the terms with y prime in them, put them on one side of the equation, put all the other terms on the other. So I'll leave these guys where they are, xy prime plus 3y squared y prime. So I left these 2 terms with y prime in them on the left side. And I'm going to move these 2 guys, 3x squared and positive y, to the other. So algebraically, you subtract these 2 terms from both sides. And basically, their sign switches on the other. Okay. Now this is good because all these terms will have y prime in them, so you can factor it out. Y prime, x plus 3y squared, and equals that guy. And now to get y prime by itself, you can divide both sides of this equation by this factor right here. So I'm going to divide this away. So I'm left with y prime. And on the other side, divide this side by that factor. And there's your derivative.